Hello and welcome to the Let's Talk Azure podcast with your host Sam Foote.
And Alan Armstrong.
If you're new here, we're a pair of Azure and Office 365 focused IT security professionals. Each episode, we talk about a specific topic in the space. This week, it's episode 3 of season 2. We're going to have a chat around Terraform, a product from the HashiCorp family of products. Terraform is arguably the market leader in IAC, or Infrastructure as Code group of products. In this episode, it's my turn to be the subject matter expert, with Alan firing some great questions at me. So stick around to find out why you should be using Terraform in your organization and for your customers. Hey Alan, it's amazing. We're on episode 3 of the second season already. How's time flying? It's insane, isn't it?
Yeah, I know. I think I was just thinking that what was our last season? It was like 8 or 9 episodes. We're already like a third, starting a third through them now.
Exactly. It feels like we've got things a lot more buttoned up this time, right? We've got our topics, and we've got plenty of things planned out for the rest of the season. So it's like we're on top of it now, aren't we? It's a bit more serious. We're taking it a bit more
Yeah,
serious now.
yeah, and it looks like we've got some time as well, and we managed to carve out the time out of family and work life.
Exactly. Definitely. Right. So yeah, should we get started talking about Terraform?
Yeah, sure. Okay, so straight off, what is infrastructure as code?
Okay. So the traditional way that you may manage your cloud infrastructure may be to use, say, the Azure portal or any of the web portals from any of the major cloud providers. That's that's a great administration tool, right? It's easy, it's accessible, it's easy for people to understand. Um, Almost anybody can use it as long as you've got the domain knowledge, obviously, of the platform. So it's a really accessible way to bring up your infrastructure, configure it, and administer that infrastructure. Um, the One of the downsides of that approach is that with so much flexibility can become some issues with control. Okay, so if you are, say, an owner, a contributor, owner, even a global admin of your tenant and your subscriptions, then you sort of have free reign to build whatever you want, whenever you want, and make any changes at any time. There are ways to limit people's ability with, say, RBAC, and we'll do a whole episode, I think, on RBAC and how that works in Azure and things like that. But what infrastructure as code does is it sort of flips that on its head. We're still creating infrastructure, but instead of configuring it via a web interface, we are writing it as literal code. Okay, so what we're doing is we are writing let's say we write a text file with a bunch of commands in it, and I'm massively simplifying it to so that people that have never even worked with infrastructure as code essentially have a list of commands, and you say, I would like a resource group, I would like 2 virtual machines, X, Y, and Z. Then what happens is you have an infrastructure as code tool. So in this scenario, we're using Terraform. Terraform will then take what you've written in that file, and it will look at it will automatically look at your infrastructure that you've got in Azure, and it will then, using Azure's APIs, it will automatically deploy those resources for you. So what we're doing is instead of allowing, and so, well, it's not about allowing, I suppose. That's probably not the right word to use. Instead of utilizing people to actually go and do the physical clicking and the changing in the portals, we're letting that code and that tool completely handle all of that, um, the deployment and management of them. So infrastructure as code can deploy new resources. It can also keep existing resources, their configuration in a state that you want, and then also it can destroy resources automatically as well if that's what you want.
Okay, so I guess if someone was coming from a development background, it kind of naturally probably feeds into how they, how they see code, how they digest that sort of process, I guess, into building their infrastructure for their applications, things like that, to help manage it in that sense.
Yeah, so there are some, I'll call it basic programming concepts in Terraform, which do allow you to do things like looping, and we're gonna. I'm guessing we will talk about that a little bit more in depth throughout this conversation. But you, yeah, if you do come from a development background, and I would also say like a scripting and sysadmin background
Yeah.
as well, because it says it's called code, but it's not really code. It's more configuration files, if anything. But yes, if you've got people in your organization that have coded before, have scripted before, Terraform's going to be pretty feel reasonably natural to those people.
Okay, so I would probably not naturally go to infrastructure as code because I've always used the various portals and things like that. So why, you sort of mentioned it, but why would I want to change? What are the benefits? I guess you've kind of said a few of them, but there must be some others.
Okay, if we just completely negate any drawbacks for the moment and we just talk about benefits, I would say that um, the two biggest benefits are first control over your infrastructure, and also your approval process for releasing new infrastructure. So, um, I'll give you the I'll give you a very high level explanation of this. Right. So what you could do is you can check in your Terraform code configuration into say some sort of source control repository. So let's say Git. Then what you can do is with say Git's, well, not inbuilt Git's, the software that's around Git, the pull request and approval methodology. What you can do is then you can bring other people into the approval process there as well, because if we have multiple people that can read Terraform, you almost don't need to see a visualization of what's going on. It's very descriptive. Like you can understand what resources are being deployed just by going through it. Um, there's also Terraform Plan, which tells you what changes are going to be made, and what we're doing is we're utilizing a piece of software to make those changes. The idea being that we have reviewed the code for that infrastructure. We've all agreed that those changes are correct to be made. Then Terraform is going to do is going to then tell you what it is going to do, and what we're going to do is we're going to trust that that code is going to be more repeatable than a human. So if we all agree on a topology, then we say, okay, Alan, go ahead and build that infrastructure for me, right? Which would be absolutely fine, and you could do that. But let's say you missed a configuration, or you left something, you left a configuration off which was important to that wasn't noticed to start off with. As long as you've gone through that QA process internally and you have tested in a development environment, and let's talk in a bit about collaboration and how that process works. But essentially, you should be at the point where you've all, just like a piece of software, you've all agreed in some sort of QA environment to then go forward with releasing that into production. And hopefully, if you've gone through all the correct steps, then that should be repeatable. So that takes me on to the next big benefit, which is disaster recovery. You've effectively got a low level design in code of your infrastructure that you've just rolled out. Let's say you needed to spin that up in a new environment, or you've got a product that you might, maybe you've got a SaaS product that you might deploy into people's cloud environments. You've then got a repeatable snapshot of the infrastructure, and it can just be rolled out at any time. So we like to also use it as a disaster recovery tool, because it's like another fail safe. If you've got to rebuild complete from scratch, touch wood, that doesn't really happen. But If that was to happen when we're talking about our disaster recovery scenario, it's much better to have all of that domain knowledge of the person that architected that solution in code so that you can just deploy it rapidly. You don't need that person to be there to redeploy it. It's so you're kind of you're taking that risk of, we call it bus number, that person's not available, they've moved on, because chances are the infrastructure was brought up months or years ago. Then there's a living document of what's been rolled out.
Yeah. Okay. So that's if I built, say, and we say, Azure Virtual Desktop environment, and I've done it all manually, and one of the regions goes out, and then I need to rebuild that in another region that's currently up. Manually, I'd have to go in and make sure I've got my low level design document that I may or may not have created, um,
Correct.
and rebuild it and hope for the best that I've remembered to do everything. What you're saying is that because we've deployed it via the script, the infrastructure as code, that in effect it's a rinse and repeat. I can spin up everything as is where it's managed by that code or been deployed by that code. That we could have it back up and running within minutes, depending on how much resource and stuff's got to be rebuilt.
Yeah, exactly. And when we're talking about disaster recovery and high availability, we should probably do episodes on both of those topics, right?
Yes.
Because what can happen is when you're talking about, say, high availability can be very expensive, right? And um some business, I won't say a lot because that's me being making assumptions, but some businesses won't want to spend the money on having a true, like, live high availability strategy, like basically doubling your infrastructure,
Yeah.
right? Some apps and some businesses can tolerate X amount of hours or days worth of downtime, whilst things get rebuilt, right? In that scenario, the overhead that Terraform adds to the architecture process, it does add overhead. But if you are ever in a scenario where you don't have a live failover and you're going to, quotes, failover manually, or you haven't even got a standby hot, customers come with all different types of requirements in terms of what they want, and it's not every customer is exactly the same. So it really does depend on a case by case basis. But if you ever think that you might need to bring it up again, it's going to be the quickest way to bring it up again, and having like the quotes LLD is quite important. The other thing that I haven't talked about, which I think I should just mention quickly now, is Terraform will also do the diff between two sets of infrastructure with you. So if we think about infrastructure isn't really a thing that you push infrastructure live and then it's just there, like it doesn't get changed. If you have new configuration to roll out, it will compute that change for you and manually do that. So I'll give you a working example that we had this week where we were configuring AVD. We decided to move, I believe it was the host pools or something, to a different resource group.
Yep.
And if you did that manually, it would be a bit of a pain because you'd have to go in, unlink things, make sure you've unlinked all the correct things, move them into the different resource groups, link everything back up. We simply changed the resource group name to the different resource group, and it computed that it needed to modify three things, destroy a few things because they needed to be moved, and it computed all of that for us, didn't it? So also when you're in your um, when when you're in development and you're deciding, you're architecting your solution, it can help you to manipulate your development environments. Then when you're in production, if you're rolling out a new version of your infrastructure, it can really help compute that difference for you
So,
and show
so
you what it's going to do.
so we talk about differences. Can that work the other way? So not necessarily that you've changed the code and then deploying new or additional, but what about if someone like myself went into the portal and changed a few things? Would it detect that change and want to correct it in some forms?
Yeah, so let's use a working example. custom RDP properties on AVD. I think that's what we were doing this week. So custom
Yeah.
RDP properties, right? It's just a string that you attach in the portal, right? Um, if I've say got a static set of RDP properties that I'm passing to, like, putting into the infrastructure, and then you come into the portal and you edit it. Now, companies can take varying levels of control here, because you could basically at one extreme you could basically say Alan doesn't need access to the portal anymore, right? And yeah, I don't think we ever live in that world. Like, I haven't, I don't think anybody's taken it to that extreme. But um, Alan goes in and updates the RDP properties, because maybe you've got a Friday afternoon reason to do it, right? And you just need to get it like working. When I rerun my Terraform plan, it's going to try and correct that back, right? And I'm going to see that change, and it's going to then I'm going to go, why is this changed, right? And throughout our QA process, we would then go, oh, it's been updated by Alan, or it's been updated by somebody. We might not know who, but we could go in and find that out, um, and then it would protect us from overwriting it. But yes, Terraform is trying to maintain its version of infrastructure, definitely.
Okay, so we didn't really talk about what Terraform was per se, but started talking about infrastructure as code, and then we started mentioning Terraform. So is Terraform uh, I guess a language, a platform that can be used to do that deployment, I guess, isn't it? And
Yeah, yeah. So
management.
Terraform is a piece of software. It's more than a piece of software. I'm going to call it a platform, because it's not just a piece of software. um, but the Terraform CLI is what you're working in to do those applications of that code. Terraform has its own configuration syntax that you would need to learn in order to use it. So it brings its own uh, I'll call it a language structure, like configuration structure, um, and then it gives you all of these things, and then there are some other sides to it. Um, there's also Terraform Cloud Services. So when we talk about collaboration, I'll go into this in more depth, but essentially, like secret management, variable management, configuration management, and state management, they all of those things need to be managed in infrastructure as code, and Terraform has a products around that to help you with those things, because they are challenges when you're doing collaboration. So Terraform is just one of many infrastructure as code tools. Um, One of the best parts of Terraform is it's cloud agnostic. Really, it's got varying connectors for different cloud providers. You can mix and match. So if you do have infrastructure that is split across cloud providers, it can also help you manage that as well. So let's say you've got an application on AWS and you want to bring up some Azure specific software, like maybe Azure has got a specific SaaS application that you want to bring up, or um, yeah, or you've got a requirement. It can help you span across clouds. So I think that's why, because the major cloud providers also have their own versions of infrastructure as code, but they are very tailored down to their own needs and their own universes, if that makes sense. So what is really good about Terraform is it's like you learn it once, and then you can apply it to every major cloud that there is.
Yeah, so you're talking around the ARM templates or bicep. From an Azure perspective, I guess in AWS it might be cloud formation.
Cloud formation, that's correct. Yeah,
Yeah, okay.
yeah,
I don't know
exactly.
what
Yeah.
the Google version is, but
But the yeah, and essentially it's kind of doing the same thing as those things, but it's also got the context of everything else
yeah,
that's out there as well. And it's yeah, it's a very big player in that space. There is a lot of people that use it, and there's a lot of community around Terraform as well. So it's quite easy to sell to people because there's so much community support, and it's vendor neutral, which is quite good, like for some people,
Yeah.
right? Because like we talk to some customers that don't want to be completely embedded in Microsoft's world. They don't want to be completely reliant on Microsoft, which I totally understand. And the same for the other cloud providers. That's not Microsoft specific. Lots of people want to try and stay like cloud neutral, if that makes sense. So, if you do have a workload, um, you would need a different configuration, but you would be able to re-terraform it on another cloud provider using their tooling, if that makes sense.
Okay. So uh, this is a question that I've been wondering actually. So if you had a Terraform project, are you saying that if you had, like you were saying, multi-cloud deployment, in effect, you could have it all in that one project, probably different configurations for each sort of cloud, but at least having it in one thing that you can then just deploy, and it will go, it will span the clouds that's supported, kind of thing.
That's correct. Yeah, yeah. So it can
Yes.
you can register you register providers. So like Azure has a provider, AWS has a provider, and then as long as you've got them registered in your project, you can use any of those providers' resources. You can even do it in the same files if you wanted to.
Oh,
Right. So
okay.
yeah, you can intermix it and everything. I'm not sure I'd ever do that, but I believe it's possible to just have everything in one place. So yeah, so if you do have, because as well, it's probably good to give you the context of as well is if you're designing, say, a landing zone, um, your it's your Terraform projects are going to span more than just one area of your
Yeah.
your stack. It could be the whole of your, you could do the whole thing, like pretty much everything in Azure. So um, understanding that a number of projects and modules, and I'm not going to go too much into depth because I want to try and keep it quite high level, but I don't want to get dragged into the weeds of it because I could talk about Terraform for like 3 hours, 4 hours, I expect, right? But yeah, it's good to understand that essentially the majority of things that you can do in the portal, you can do in Terraform, and that can be your new version of the portal. You could read the code. It's kind of like the Matrix, right? Instead of looking at like a web interface, you can look at all this code like streaming down the screen. So yeah, you can pretty much. It's very flexible from that perspective.
Yeah, well, I guess in that sense, it's an offline portal. You don't need to have
Exactly. Yeah.
connectivity to be able to work on it or
Yeah.
see
Well.
what being configured.
Yeah.
Um,
Yeah. Exactly.
yeah. Okay. So what about then if um, I've got something that is almost like rinse and repeat. I need 10 of them, and they're all named differently. They may have a slightly different configuration. Do I have to repeat that code, or is there a way of trying to, I don't know, dynamically configure it, or try to loop through it, I guess.
Okay. Yeah. So what's great about Terraform is I don't know the official wording that I should use for it. I would call it composable infrastructure, dynamic composable infrastructure, however you want to think it. So yeah, so like you may have a requirement that let's say you've got a managed service for your customers, right? And let's say you've got 10 customers. So it's cool. You've got your 10 customers. Then once the 11th customer comes along, maybe you want to add some infrastructure, your side for that, thing. And that isn't that could be a managed when I talk about managed service, it could be anything from, a SaaS platform, managed service, like, and it could be anything, right? What we sometimes do with Terraform is we base our configuration, well, our infrastructure on configuration. So what we sometimes have to do is like say loop through infrastructure. So let's use a really simple example. Let's say you needed a resource group for every single one of your customers. Super simple to do, and actually in the portal that wouldn't be too onerous anyway, right? Um, but in Terraform, what you could do is you could create a list of those. You wouldn't create a list. You create a map, but I'll just use the word list to make it simple in people's minds, right? Create a list of those customers: customer one, customer two, customer three, X, Y, and Z. And then what you can then do is you can then do a for each. loop through those customers. And you can say, for each of these customers, create me a resource group. And I want that resource group named, because the name would have to be different, because we couldn't have 10 resource groups of the same name. And then you can sort of, as you're building those resource groups, name them differently. So those constructs are in there. And from that perspective, it is very much like coding, because it's those simple control statements like, ifs, for loops, and switches and things like that. That you can do there. So yeah, composable dynamic infrastructure. It's probably got an official name. I'm not 100% sure like what the correct way of doing it, but to have that dynamic flexibility is really, really, really powerful, because we've talked about it from a disaster recovery standpoint, and we probably should have talked about this at the start. But yes, if you do have an infrastructure that is growing and shrinking as well, like when a customer goes offline, do dependent on your policies, you should maybe remove all of their, it might be that you have to remove all of their data from your systems, right? So Terraform can also help you to go and clean that up afterwards as well. So yeah, definitely that is supported, and another really powerful thing in terms of scaling infrastructure.
Okay, so can Terraform help you with naming conventions and things like that? Making sure that there's always I know in the Azure world, the naming recommendations from Microsoft, prefixes, things like that, or even parts in it. Is there a way of making it simple for that to be almost rinse and repeated throughout the different resource, I guess, or resource types?
Yeah. So in the Azure world, we probably call it the Cloud Adoption Framework, which is a framework to help you migrate to the cloud and build your infrastructure in the correct way from the start, in Azure. And part of that might be that you define yourself a naming convention, which is usually the hardest thing in Azure, to be totally honest with you, is the naming of
You
things.
can never change it.
Um,
Yeah.
yeah, and the joke is in computer science, that's the hardest thing, just naming variables, naming things, right? So, I'll give you an example. With Azure, there's I think it's a module that you bring in called the Cloud Adoption Framework naming module. And what you can do is you can say, for this resource, I need a name, and you tell it what type of resource it is, and you say, it's a resource group. You give it some other information that you might want to put in the name, and it will generate you a name automatically. No typos, nobody moaning about anything, right? Because it's named incorrectly, because it follows like standard cloud adoption naming. You could create your own module for naming if you wanted to tweak it, and X, Y, and Z. But yes, yeah, there are loads of in the world, in Terraform's ecosystem. There's lots. If you've sort of thought about it and you've got a problem with something, somebody's probably already been there and done it like way ahead of you, right? So yes, but naming, like you say, that can sometimes be a not a challenge, but just to how many times have you made a resource and named it incorrectly and had to delete it and start over again? Because once you've deployed everything, you've realized you've named it. And then most of the time, everyone's like, it doesn't matter, but it'll just bug you forever, because it's not. Do you know what I mean? And then
Never
if you
been there.
notice somebody,
Never been there.
yeah, and then if you notice somebody else has named something incorrectly, then you're just, exactly, you're going to point it out every time you see it, right? So, not you specifically, I mean, the proverbial we, right? So,
No, I've been there. I've been there.
yeah. So yes, from that's a very basic benefit of of Terraform, but yes, it can help you with your naming 100%, Alan.
Well, well, like you said, it might save some time of you trying to work out what you should call it. It's just done for you.
Time is money, and yeah, it's important that from my perspective, because I sort of sit on more of the infrastructure side. I'm really there to make sure that what the solutions that we've architected, both internally and for our customers, are built to the best practice possible. We practice what we preach, and we follow the quality standards that we've got internally. And I feel like Terraform's got my back with a lot of that stuff, right? And I could be, because I come from a coding background and developers are lazy. That's the whole point of developers. They're there to automate everything, right? Like that's the brain that they've got to have. So for me, it's like, why would I click around the portal when I can just write a config file, right? Like that's the way my brain goes because I'm lazy. So yes, so it can definitely help with standardization for sure.
Okay, so let's go on to collaboration. We kind of mentioned it a little bit. Is it easy to collaborate with these projects? And the deployment part of it, because you know these files could be sat in a OneDrive or something like that, and someone could make changes. I guess it could sit in a repo repository.
Yeah.
Um, but yeah, can it can people collaborate with that code and still deploy? I guess it's going to talk around the state side of things.
Yeah. So okay, so a quick primer on Terraform, like Terraform 101, really quick, right? So you've got state, which is what Terraform computes of what it knows about your infrastructure. So what it does is it goes and looks at Azure and it says, okay, how is everything configured, right? And if it's the first time you've deployed your infrastructure, there's nothing there. So it's all a brand new state. When you apply it and it actually does the deployment, it then locks that state into a file locally on your machine called a state file. Then when it comes to do the next version, so you want to roll out your change, it looks at its local state to compute the difference, right? And that's how it then tracks. So you've got state management, you've got secrets, credentials, and secrets. So, like, let's say you're connecting with a service principal and a secret. That's a really simple, authorization mechanism. Um, so, how do you manage those secrets, especially in a shared environment? And all of those things. And then you've got variables as well. So, when you create a Terraform config, you can pass a number of variables to it. So you can say like, what's the if I'm creating a virtual network, what's my address space look like? Let's say, and you could pass that in as a parameter, as a variable into your thing. So variable management, secret management, and state management. When you're talking about two people interacting with each other or a team interacting with people, it can get kind of complicated. State management is relatively easy to do because and a big thing to preface with this, you can just pay Terraform to take your problem away. They've got Terraform Cloud. You pay for Terraform Cloud, and they will fix all these things for you because they are challenges.
Okay.
So yeah, you can do that. Like there's nothing really wrong with that. There's a free version. There's like a standard version, I think they call it, and then there's an enterprise. If you want your SSO and everything else in between, right? So if you just want to out the box go and do it, then talk to Terraform, get yourself sorted out. Um, if you want to stay like on your provider, so for instance, state management can be states because they're just JSON files, can be stored in a storage account in Azure, right? And what that then means is anybody that then tries to run to deploy that again will be able to read that remote state. So it's not just on your computer; it's like on a shared repository there. And what then happens if you have remote state? What's cool about that is you do get that sharing, so me and you can deploy whenever we want. But the main benefit is that let's say you have a project that let's say you've got your landing zone project, which does all your networking and all your and everything else in between, right? Let's say you need to reference infrastructure from that project. If you have shared state, you can import that state into whatever project you're building and then use it. So if you're like, right, I want to connect my app to this virtual network, then you can pull the state from another project if you've got it in shared state. And I've whistled across that really quickly, but essentially what it means is it means that you don't have to have one big project. You can have multiple projects and reference state from all of those different projects in your new project that's come up online. A lot of infrastructure doesn't really need that because sometimes people are just deploying like a workload after workload after workload. But sharing the state is important for deploying because without your state you can't redeploy. It's horrible if you lose your state. You've got to like you don't have to start from scratch, but you might as well at that point, depending on what's stored there. Um, and then this being able to reference other states and other pieces of the infrastructure is also important from shared states. That's great for collaboration. And then secret management, we use environment variables, and we in our development environments we all manage our own secrets and local state for development. Um, and then variable management as well it's a very similar thing. Those configuration parameters that we're pushing to Terraform, we're managing those ourselves. Then when you take it into, say, a deployment pipeline, so really best practice is to then use some sort of DevOps pipeline, GitHub Actions, um, Bitbucket's equivalent, Azure DevOps pipelines, whatever it is, right? Doesn't really matter as long as it's some sort of operating system that can install Terraform. You can use it. It doesn't really matter. Um, so, for instance, what we do, and I'll just explain like our basic
Yeah.
setup
Okay.
is that we have a Git repo with everything in it, and we have multiple branches. We have a develop branch, we have a staging branch, we have a production branch. People will work on their own feature branches. They will then target develop, which is our first gate. Develop will be pointed at the infrastructure for develop will be pointed at one of our dev tenants. We'll open a pull request from our feature branch to develop. The team will review that and they'll say, "Yep, we're happy with those changes." We'll usually involve the stakeholder with that as well, and get them to, we'll talk them through it. If they don't understand Terraform, we'll talk it through with them and explain what we're going to do. Then once we accept that pull request, it will then land on develop, and a pipeline will kick in. So a DevOps pipeline will kick in, and it will go, "Okay, I know I'm on develop, and I know what that infrastructure should be. I'll do a Terraform deployment against that infrastructure." And then what it'll do is it'll automatically deploy to develop. It'll just overwrite it. We'll then go and QA develop, make sure we're happy with it. And develop is really like, it's nowhere near close to production. It's like a sandpit environment, like that is, very consultant developer orientated. Then we'll move it to staging. So we'll open a pull request from develop to staging branch. Once that's approved, so let's say we go back a few times on develop because somebody's screwed up somewhere, right? Because it happens all the time. That's how the world works. So we've got a QA process there. Then we go from develop to staging, where it's more like the actual infrastructure that it is in production. We try and keep it as close as possible, not in terms of data because we don't keep any um, sensitive information in our staging environment. So it's all fake data, but it's very close topology wise, like networks and things like that. Except for anything that's expensive, because we don't like to run expensive things in our staging environments. And then we'll validate it there as well, and we'll make sure we're happy with it. And then once we're all happy with that, we'll open a pull request to the main branch, um, the master main, whatever you've now called it, to the main branch, and then that will then deploy into production. And what we're hoping is that by the time we get to the end of that feedback loop, that we've ironed out all the niggles. All of the technical people have been involved. They've seen it actually be deployed and go through. We also have some other technology that helps us with documentation as well. So we might run that on it to see what's going on there. We won't go into that. That should probably be its own separate episode as well. So we'll go through that process. And so this isn't just somebody jumping into the portal and then configuring it and seeing if it works. It's actually like a process that we go through, and a continuous process that we go back and forwards on.
Okay, so that's controlled testing at that point, isn't it? Where if I was doing it through the portal on a dev or staging environment, I may do it one way that time and maybe forget in production and cause an application issue or the service to go down kind of thing. So that's really good that you can almost you've done pretty much all testing you can possibly do, de-risked everything as possible. It could still go down. There may be some other thing missed, maybe, but at that point, I guess there shouldn't be
What what
anything.
what you usually don't, I in my experience, things don't usually go down because they get noticed very quickly,
Yeah.
especially at the people going down. It's the nuances of what's not configured, right?
Okay.
It'll be 2 months down the line that you've realized that you've allowed people to copy and paste to and from AVD because you accidentally missed that configuration.
Yeah.
A really nuanced configuration, and maybe your compliance policies weren't enforcing that, or weren't in depth with that. That's the sort of thing that you're trying to, you set your config once, and then you're safe in the knowledge that Terraform's going to have your back every time you want to deploy it, right? And it's
Yeah.
going to make sure it's correct every single time. So yeah, that's the sort of areas that I screw up on. And I think a lot of, and because we're all human, right? And I think that's what we've got to always go back to is that, yes, the portal and, Azure or any cloud provider, any software is really good at doing what you tell it to and doing it well and repeatable, right? So if you tell it, it's always us telling it, well, the majority of the time, it's us telling it the wrong thing to do, right? And that's what we're trying to avoid as much as we possibly can, because we we understand that humans are human. Like it's not to say X, Y, and Z consultant always makes mistakes and always forgets things, right? Because sometimes you need to do things really quickly. You might get like an urgent requirement that comes in out of hours, and you just need to like get something done and move on.
Yeah.
And you might not even document that. And then what might happen is in the future you've got no. So what you could do in that scenario is you could go in and make your changes, and if you don't think it's going to be that too impactful, you can just say, right, I've made all the changes, I've got this up and running. Tomorrow you'll go and do a Terraform plan to see what the difference is of what you actually did, and then compute it back into the config for Terraform, right? So it's also it's a way to self document as well, as you go through. You can't do that all the time. I usually advocate don't edit the portal if you possibly can,
Yeah.
right? But it is all unlocked. You can just go and edit it.
Okay. So pricing. So we've talked about cloud, Terraform Cloud for the state management, things like that, and there's some other services. But is the CLI, how much does that cost to use?
Costs absolutely nothing to
What,
use.
what do you mean?
S-
What how
I
can it be
know.
free?
I know. It's like they're good guys. So business model of um, HashiCorp have got a family of different products, and what they're really selling is their Terraform. I'll call it their managed service, Terraform Cloud. That's what they want you to adopt, right? And I don't think they've personally made it complicated, in order to sell you that, because I think there's some core principles of infrastructure of code that they're actually helping you with, helping you to solve. So that's where the money is for them. And we we don't really use that service because we don't resell it, and we also don't have control of it, if that makes sense. So we do like to keep things a little bit in house because we've also got the DevOps and management experience in house to be able to do it ourselves, right? So if I was coming at it new and I was a new organization, I would maybe think about looking at Terraform Cloud because it can get you up to speed very quickly if you don't have people in house that maybe you're retraining some of your staff to use it, and maybe it's not fair to lump them with all of that to learn to start off with, if that makes sense.
Okay. So what other products are out there? We've talked about Terraform. What else is out there that can do a similar thing?
I think from a cloud perspective, and I'm just talking cloud because this is the Azure podcast, right? I think the other main way to do it, and we've briefly talked about this, is the actual cloud providers themselves. That's what I would be looking at, and that's what we've done for a long time, isn't it? ARM templates, you know, and new bicep. Like it's the way that it's done in our world, right? Um, so but what this can give you is it does give you that extra level of collaboration and state management, which those other tools don't particularly give you, or they're complicated to do. Um, and also, it is completely cross-platform, so you can skill in one thing, and it does matter, but it doesn't really matter what cloud provider it is because you know if your client decides they don't want to use storage accounts and they want to use S3 buckets for some weird reason, who knows, right? But like, let's say they had all of their infrastructure. I'm not saying that S3 buckets aren't, worth using. I didn't mean it like that. I meant it like, in the context of their application. Let's say they had a, part of their application which required an S3 bucket, and you can just add it in and have another resource in your dependency tree, so because it might be that one of their modules requires S3 buckets, so it does give you that flexibility when those requirements come in.
Okay, cool. So we've hit 45 minutes, Sam.
Okay,
We've
that's it. Our
we've
time is up,
yeah, sit
everybody.
right. See you later.
All
No.
right.
Okay, so
I
let's do
apologize if I
a
missed anything.
yeah, disconnect. Okay, so let's do some reflection about what we talked about. So, infrastructure as code, is a way of controlling your infrastructure, and also deploying it um, rapidly, and making changes, and helps with potentially disaster recovery, things like that.
Yeah, that's
Um,
correct.
where we're able to do um, in effect looping to help expand or replicate resource within an environment if needed, to expand and contract that environment within minutes, within seconds, rather than it being done manually.
Yeah,
um, it works in the main cloud providers, so it is cross-platform, and I guess it depends on if there's a module for other services like maybe Azure AD, things like that. Then you can do some configuration in there. Um, but in general, it's pretty much any resource within a cloud environment. May take a while for maybe some preview stuff to turn up in it, but probably are quite on the ball of getting it into their solution. Um, and as you kind of said, it is really an industry leader, because it's multi cloud, cross platform, um, and the kind of things that we can only see is the actual providers giving infrastructure as code and deployment processes, um, specifically for their clouds, kind of thing. Does
yeah,
that kind of sum
exactly.
it up a little bit? Is there anything I
Yeah,
missed?
yeah. I think just to touch on your point, a couple of points there, when we're talking about different providers providing different things. So in Azure, there's Azure Resource Manager for resources in Azure, and there is Azure AD. So you can do group provisioning, role provisioning, all of that good jazz and things like that. So there's different elements to each of those cloud providers as well, which is important because it does cover a lot. And you were just talking about like private preview to GA and how
Yeah.
that works and things like that. There are definitely some gaps in Terraform. Terraform does allow you to deploy ARM templates as well, so you can kind of fill any gaps. You can kind of manually fill any gaps even with Terraform as well. Um, so there's that, and yeah, so I do have good confidence that the velocity at which they work at releasing, connectors and configuration for things, it's very close to when things go GA. If you're in public or private preview, then you're probably going to be doing things manually because you're also probably learning those technologies. You're maybe doing beta deployments with customers. You might be doing internal projects and things like that. That is where you get your domain knowledge and all of that sort of stuff. And then when you come round, once it goes GA, because obviously nobody uses anything that's in public preview and production, do they, Alan? Right. So when it goes GA, that's the time to build your Terraform and quotes do things properly, if that makes sense from my perspective. So yeah, yeah, no, but that's great. I think you've absorbed, and I mean you've worked in and around it with me anyway, haven't you? But hopefully that's given you a good insight into Terraform.
Working with you with it, and yeah, maybe directing you what I need in it, maybe.
Well, sometimes that's what I feel like. We mentioned earlier that we were doing AVD, and Al's got loads of really good AVD knowledge, and I'm just sitting there like a puppet typing into the code whilst he's going, "Can you change this? Can you change that?" And I'm like, "Yep, yep, yep, I can do that, not a problem." So that's from a pair programming. I call it pair program. A paired work. Somebody that's Terraform can extract that information out of like a subject matter expert's head and deploy it as infrastructure, right? Which I think is really powerful as well. We can see that happening, the collaboration that we do day to day, right?
Yeah.
Okay, right. So we have gone way past time, so I'll get through these bits. So to let you guys know, we've made a plan now for all of our episodes going forward, and so we're sort of going to forward shame ourselves into making sure we record and things. So I'm going to just tease the next episode. We're going to be talking about modern device management. Alan is going to be the subject matter expert, and we are going to be going into topics such as Alan, give us the 5-second high level spiel on modern device
Uh,
management?
you know, multi device management, securing them, simplifying your deployment, I guess, onboarding of new devices, things like that.
Okay, great. Yeah, so and if you've enjoyed this episode, please do consider subscribing if you'd like to listen to more of this sort of content in the future. We have loads of topics that we'd like to cover going forward, and your listens and your support is what will continue to fuel the podcast going forward. So thank you, everybody that's listening and that's subscribed so far.
Yeah, thank you. And we've managed to get some the ability to do to get your feedback. So if you enjoyed this episode, or you disagree with us, or we've missed
Probably
something
that's going to
out,
happen
because
quite a lot. Yeah.
yeah, it's probably going to miss something out, or we haven't got time to do it. Um,
Yeah.
Feel free to, in the show notes, there is a link to a form where you can put some feedback in, and then we'll capture it, and we can potentially reply back, or we can talk about it in the next episode or something like that.
Yeah, and we've already had feedback from other listeners, so thank you ever so much for the people that have submitted feedback so far. It's great to capture your feedback, and especially for new topic ideas, new episodes, and things like that. It's really good to get your feedback. So if there's anything you want to hear from us, please do let us know. Right, we've gone way over time, so thank you everybody for living. Thank you ever so much for everybody for listening, and we'll catch you on the next one. Cheers.
Yep, thanks everyone. See you next time.